Hello and welcome back to another episode of Math Bliss Zone. Today we're going to be dealing with conditional probability and two-way frequency tables and things like this. So let's say you're given a problem like this where you're just given this two-way frequency table and it says find the probability of you being a junior if or given you were at school on a Friday. Okay, I don't know what the actual problem is, but this if part is very important because anytime you see if or given, that would indicate to you that you are only going to have the Friday people or the Friday stuff in as the total. So here, given that it is on a Friday, there is 45 and 40, meaning 85 total people there on Friday. And out of those, how many people are juniors? 45. So it is 45 out of 85 that are juniors if it happened on a Friday. Okay? Now you could change this problem up a lot. You could use the same two-way frequency table in a lot of situations. You could change it to saying find the probability of you being there on Saturday if this big bar means if I should have probably shouldn't have had the parentheses there. If it happened to be that you are a senior. Okay, so this means find the probability that you are there Saturday given you're a senior, or if you're a senior. So you're going to make the total out of the seniors. So there is a total of 160 seniors. That would be the bottom of the fraction. And how many people were there on Saturday out of that? 120. So it'd be 120 out of 160. Yes, of course, you could simplify it. I like to sometimes keep it in the raw form. That way it stays that way. Okay? Other questions are going to relate to whether or not they are independent or not. Okay? So given this scenario, we got two machines produce light bulbs. To ensure the quality control company randomly tests light bulbs for defectiveness, are the events of producing a defective light bulb and coming from machine B independent? Justify your reasoning. Okay, so in order for events to be independent, I'm going to have a whole other video on this as well. It is if you take the probability of A and multiply by the probability of B, does it equal the probability of A and B occurring? Okay, so that is a fancy way of saying, is one event going to affect the other? So you can do it mathematically with the formula, but I find that sometimes it makes it a little bit more difficult. You can also think about it as, is the fact of becoming a defective light bulb dependent on you being produced by machine B? And you can look and be like, well, there are defective light bulbs in machine A, and there are effective light bulbs in machine B. So is just being made from machine B going to guarantee that you're a defective light bulb? No, you could have been a defective light bulb from machine A. So these are not really dependent on each other. Now, so this is they are independent events because they are not affecting one another. Now, if you switch this to 0, now you're looking at a scenario, if you're a defective light bulb, could you even come from machine B? No, you couldn't. That means that being a defective light bulb would be dependent on it being produced at machine A. So you can think of it from that perspective too. Other scenarios may require that you multiply probability of A and probability of B together to figure out if A and B multiply and equal each other. Normally with two-way frequency tables, one is dependent on the other because you are given some other information. Okay? So, more conditional probability. Let's do football. A high school football team has a roster of 88 players with 32 seniors. 13 of the seniors also take drama. Of the 88 players, what is the probability that a senior is taking drama? So, of the 88 players, what is the probability that a senior is taking drama? So how many of the seniors are taking drama? 13 of the seniors are taking drama out of the 88 players. So this is as simple as saying 13 out of 88. Not all of them are going to be that easy. Let's see if the next one is a little bit more think about it. Shuffling a song. 100 songs are on your MP3 player. Boy, this worksheet is dated. Divided into 2 playlists containing 50 songs each. So, the student's favorite song is on playlist A. What is the probability that a student is going to hear their favorite song if playlist A is on shuffle? Well, if we have playlist A, we have 50 songs. That is the total. It's not going to be out of 100 songs because we're only on playlist A. And how many of their favorite songs exist? Just the one, I would imagine. Favorite means it's your favorite, and that is all you have. All right. Let's look at one that a lot of students struggle with. A pair of 8-sided dice are rolled. What is the probability that the sum of the 2 numbers is rolled is 12 if or given the first dice chose a 7? So essentially this happened like you rolled 1 dice and it showed a 7, which is weird because it's an 8-sided dice. Then you roll the second dice. You got to kind of think you're now rolling the second dice, even though they were both rolled simultaneously. You peeked at one of the dice, you saw a 7. What are the chances that now the sum is going to equal 12? Well, on the second dice, you would need a 5 to make it equal 12. Well, what are the chances of you rolling a 5 on an 8-sided dice? Well, the chances of you rolling a 5, there's only 1 5 on there, I would imagine, is a 1 out of 8 chance. Okay, so the fact that you rolled a 7 actually influenced the chance of you getting a sum of 12 to down to 1 out of 8 chance. Now, what is the chance of you rolling a 12 in general? That's a whole different question. So rolling a 12 when you have 2 dice that actually are 8-sided would be completely different if you didn't already know that the fact that the first one was a 7. After that first one is a 7, you're narrowed down to a 1 out of 8 chance that you had a 5. If you're rolling both of them in and of themselves, the chance of it actually rolling and equaling a 12 is pretty high, because in order to get a 12, you could have gotten an 8 and a 4, and a 4 and an 8, and so on and so forth. You could even get a 6 and a 6, 7 and 5, 5 and 7. All of those would give you a 12, but only one of them would give you a 12 if you've already rolled that 5, okay? That's going to do it for this one. Until next time, stay positive, everybody, and I will see y'all later. Bye.